which was bought or which okay yeah, which we bought that to do some experiment, electrochemical experiment, or maybe the IV characteristics of some solar cell or maybe photodiodes, anything which is sensitive to light and shows the effect of the light in its current and voltage. So this setup is basically to study such systems, and so for that you need generally light means we think of sunlight, particularly for solar cell or photocatalysis is more important. So for that you need an artificial sun, and this is the artificial sun. Now artificial sun means that sunlight, when it reaches to the atmosphere, it contains certain spectral distribution, and then it has certain homogeneity, spatial homogeneity in space, and also the temporal fluctuation in time. So these are three quantities which are important for the sunlight, and particularly when you do some characterization of your solar cell or photocatalysis, etc., photodiodes. So, say for example, you cannot use the proper sunlight now in this world, but so you produce a artificial sunlight here, and what is used is the xenon lamp inside. Xenon lamp has a spectral distribution which matches very closely to the sunlight. And these are some special xenon lamps. Xenon lamps, probably you have seen that in some party or something, you see these lights going up in the sky, right? So those are also xenon lamps, but they are not this high quality xenon lamps. But as per the xenon lamp radiation is not the same radiation as we get in the atmosphere, or the terrestrial radiation of the sun, because the sunlight comes through the atmosphere, and that actually absorbs this infrared component and all these things. So for that you have it. You can count if you have the practice. So you can So here there is you can see it's called 1.5 AM filter. This simulates the atmosphere here, particularly in the tropical region, where we have. But if you are going to say North Pole or South Pole, then different filter form. You can check in Wikipedia that this type of what are the different AM filters are. So this is equipped with the AM. So whatever light you get here is the light, sunlight at 12 noon you get here.
What is the luminance intensity?
That is 100 milliwatt per centimeter square. That is one sun. 100 milliwatt per centimeter. So at 12 o'clock you get it. When the sun is directly overhead, you will get, when you have the 1.5 filter, the same intensity as you get it here. That's defined as one sun. So now we can switch on this. Okay. Before that, so this is a configuration. Say if you are trying to study a photograph or a solar cell. Many people make here solar cell. Sir also makes solar cell. Configuration where you will use it if you are studying an IV characteristic of a solar cell or photograph. So you will place your sample here, connect this with the IP, and you will illuminate your sample with a one sunlight, one sun intensity, or you can change the intensity also. That we will show later when we operate. Okay. And so, but for the photoelectrochemistry or photocatalysis work, you have to, there probably will be some electrolytes here inside, and you will put your sample through this. There are clips here, anyway. You put your sample here. You will put your counter electrode here. Okay. You will put your counter electrode here. Maybe some reference electrode here. So in that case, and these surfaces are made from quartz. Quartz doesn't affect any. Yeah. So in that configuration, for that, so the light has to enter through this surface. So there, this orientation is not good. So for that, you can just loosen this knot and you can turn it and then tighten it. So in this, and of course you have to adjust the height of this. I am telling that one sun. Say for example, if you have a light source here, if you are standing here, the intensity is small. If you are standing here, the intensity is less. Similarly, it will be this focus. So basically, you can adjust the height also, distance also from the source to adjust your intensity. And that's not a very big thing.
So what is the standard distance?
Yeah. So this distance is the standard distance. From here, you have to subtract 9 millimeter. So from this distance to this distance, subtract 9 millimeter from here will be your distance where you will get the one sun for a particular current which we have
So if we put the substrate or catalyst on this platform, we should supportably this is the reaction is carried out in this one now, and the distance between this one is the here.
No, here actually you have to turn it this way.
Yeah.
Okay, so like this you have to turn it. Then you have this also here. So you adjust the height like this, so that light falls here.
This distance must be
This distance, not this distance. Where is your working electron? Where is your working electron? So that distance has to be
9 centimeter.
no,
9
not 9 centimeters.
Okay, 9 millimeter means that is the 1 centimeter approximately. Less than 1 centimeter.
No.
That is not possible.
No. This distance minus 9.
Okay.
Yeah.
So in approximately 9 centimeter. आपका जो catalyst runner by चाहिए electro,
हाँ.
approximately 9 centimeter from the source.
So what I mean that this is now calibrated. But if your sample size is very small, then it's really uniform everywhere. We have calibrated in a 4 centimeter. So this uniformity, which we have calibrated last time when we came, spans 4 centimeter by 4 centimeter here. So we have calibrated the sample the intensity, keeping the sample. So I am telling you that I'll come to this later. So
सर एक मिनट
हाँ
इसी पॉइंट के ऊपर आपको डाउट है कि आप वो लीजिए तो वो क्लियर हो जाएगा समझ क्या
So this is a standard reference diet. So under one sun it gives 571 microampere of current. So we have kept this thing here and over the 4 square centimeter we have measured the voltage. Okay, and it's less than 2%. So this the sensor here, there is a photodiode of this. The sensor here is 9 millimeter up from this cable side. So your distance is basically from this. Okay. So it is just you need to measure it with the scale. What is this distance? And then if you have doubt, you call me or WhatsApp me. So this is a xenon lamp, and you can adjust the current to change the intensity. But every time you adjust the current, go to a different intensity, you have to use this to measure that at what distance. Say when you are pressing it like this with a photoelectrometer set, then you will measure the distance accurately. Okay, and then you will place this sensor also at the same distance and measure that was the current it is showing. And that's a linear equation. For one sun it is 571 microampere. So if you are getting say 400 microampere, then that means which sun it is. And in paper actually you will only say that I have done this experiment at this sun intensity with 1.5 filter. Okay. Okay. So yeah, you can switch it on. So for switch it on, I think it's better that only some of the people operate it. Yeah.
First power source तो second.
Now any doubt कि ये distance जो है usually how you standardize it या उसका intensity.
Okay. So when you ये लैंप ऑन हो गया. Yeah, manual. Fine. Yeah. So right now at 5.7 ampere, this is one sunlight. Why intense? Because it's a black surface, you will not feeling. But you see, yeah. This is very intense. And do not look at it when you use a sunglass. The button for shutter open and shutter close. You can close the shutter and you can open the shutter. Switching of this thing is one should be very careful, and I would suggest that. See, I understand that you will use it as a, common facility. This is a big sensitive instrument. So I think this switching off and switching on should be only 2 or 3 dedicated people who will be doing it.
Yeah, sure.
Okay. So right now Mayuresh has. So switching off is not like switching it off directly. And then you have to first shutter off, shutter close, then lamp off. And if you do the lamp off, you will see that there are, this will take about 6-7 minutes. There is a fan at the back side which is going on. This fan will stop and then only you can switch it off. Let's down to this one. And generally, after you switch on this SME source measure unit can source positive voltage, negative voltage, can source positive current, negative current. That's why it's called 4-quadrant power supply. And it can also measure the voltage, current. So right now or collecting the IP data. So maybe for the catalysis work also you need the IP data only. For solar cell also you need IP data. For solar also you need IP. There is an analysis software part of that is only meant for solar cell. Because for other this thing you have to use your own analysis. Okay, these you can use manually also if you just want to measure, and or you can use the class. Like you place the menu here and source. And plus is positive here. Now going to measure the current. So we will measure the current and this will be and voltage source. But we will keep the voltage at 0 only. And I am just showing you how to do it manually. So for that I have to increase the compliance current, because if the current increases beyond this 105 microampere, then it will stop measuring. But here I am expecting is 570 microampere. So I put the current as 1 million. Now I am going to, so it is already source, say it is at 0 volt, 0 MV, so I do not have to do, and it is measuring current too. So if I just, and this trigger I have made it in the continuous mode, and then if I put the output on, I will see that there is this 5, instead it's written 571, but we allow a 2% fluctuation, so this is within 2%. This is 560 microampere. So at 571, 2% is plus minus 30 microampere. 30 microampere. So if I now want to do a IV measurement, which I will do with this software, then I open this software and I have to just enable it, and then they just put here. But you are not okay. This is see the current at 0 bias voltage. Okay, actually. So this you are not going to use it, and this you will keep it in some set classification. Only when you want to measure the intensity, then you will get it. And this should not be dropped or anything, because it's a very expensive. These I think cost 1.5 lakhs this time, because this is a calibrated. So okay, let us start the experiment. So I can start experiment. Start experiment. here it shows the IV curve. Here it's time versus time. This will be the same. Okay. I did a mistake here. Let us increase the voltage state by for 2 or 3 seconds over this tab. It will show you that. Okay.
So ideally, what should be the wait time before running the experiment?
It depends on maybe say. See these are. I think there is no ideal system. It is completely dependent on experiment. So for electrochemistry experiment, many people want to start with take the system to a completely oxidized state.
Yes.
And then you know that you have to wait for 1 second there, 3 seconds there to get it completely oxidized. And then that wait time should be like this. Okay, but so this is like, I mean, if you want to do any particular experiment, you send us the paper you want to follow, then we will give you this. Otherwise there is no general guideline. For example, this is a semiconductor. Here the dynamics is very fast. But if it is a perovskite source, then the dynamics is very slow. So then the millisecond wait time may not be sufficient. Because whenever you are changing the voltage, you want the system to be in the equilibrium in that new voltage. So here it is very fast, but in perovskite it may not be that fast. So you may have to wait for a second, 2 seconds, something. So it completely depends on the system. Okay, so this is a graph you see typically for a solar cell also. It gives you some parameter, and last time we has checked that this matches with the parameters which has come with this calculated cell. Okay, now there is another thing, right? Though there is almost no IR radiation here, no heat, but still it is hot. You can see it's hot. So when you are using the reference diode, it is exposed to, this is at 25 degrees Celsius. This is calculated. As you know, if you increase the temperature of the diode, its IV characteristics gets changed. Okay, so then it's better to close the shutter so that it is not exposed to that. Okay. Where whatever I want to say about this instrument or the instrument that we have supplied and how to use it, basics of the instruments, and now I think we can answer the question. So the fan is to which I mean, the air coming out from the fan is pretty hot. And not pretty hot, you can come and see. Yeah. It's hotter than the angle. This one, right? I mean, not much hotter, right? It's hotter. So that much of heat it is dissipated. So when switching off, you have to wait till the fan is.
So sir, does the instrument need some charges? As like we know that
It's power.
only the power supply is that
Can you zoom it back? See, this is the lamp which is inside. This is the lamp. So this takes power, and this is 150 volts. And one has to handle it very carefully, right? No grease on the glass, and grease on the glass, and use it with gloves.
Sir, what precaution should we take while performing that electrochemical reaction?
Precaution? Just don't drop it.
Means the source we will tilt it, so it won't affect our eyesight or something.
I think, I mean, ideally I would say that you shift this here. This is ported. Okay. I mean, you can. It's just 8 kg. You shift it here, little this side, not much, and turn it back. So then it is safe for everyone. And here also, like if you do it, I mean, you will not look in this.
So our source can move both the ways.
360.
360. Okay.
360.
So it's okay.
So if you loosen it completely, this part will come out. You guys set up some experiment, when you really want, and then I'm sure you will do it. Say, photocatalysis experiment.
Electrochemistry
Many
photocatalysis.
people do photoelectrodeposition experiment. That is also, so there you need this electrode. So this is a working electrode. This is a glassy carbon working electrode. You can see that it's perfectly polished. There is no scratch. Right. There is no scratch. So there is a polishing plate there. Generally, glassy carbon is very less reactive. So here generally you put your catalyst. Generally it's a rock casting, the rock, and maybe you can rotate it a little bit to spread it. And so to remove that catalyst, generally you clean it with the solvent of the catalyst or with the distilled water. It should clean. But even if that is not clean, then you will use that polishing kit, which has several alumina suspension of several granular size. There is no scratch or anything. 0. The lowest one is good. So you take a glass plate or a flat surface glass plate. There is a sticker here. So you remove it and put it, paste it, and then in this surface you drop off those alumina suspension, and then you make figure of 8 you polish till you get that reflecting surface back. And you know this is platinum, so you should, I mean, this is expensive, so you should not bend it or handle it in a way that it breaks. So you should do it in a careful way. Okay, and there is a way of filling it. So when you use it, you have to remove this cap. Usually the cap is like this. Okay, and you always should put this cap back after using it. So after using it, you will wash it with dry water, and you should put this back because this frit, this is called frit, this is porous. This frit should not get dry. If you are having a very tightly airtight this thing, then this will make it sure that this fits. Now, to refill the solution, you contact us. Electrode. And this will go, so this is your quartz electrode. This central piece is your working electrode, or if you want to put back working electrode, it will not go into this because that is meant for some other electrode.
Sir, just if you take the technical request here.
Sorry?
Just I'm requesting you one thing. So just I don't have idea about the instrument, what is the use of it, just a general.
I'll just finish this and this electrode then will get
What is the use, why we are using and that.
Yeah.
So we are zero in it.
Yeah.
So just to consider it and then.
Yeah. So
Yeah.
this is another reference electrode. Reference electrode you know in electrochemistry. This is AgAgCl reference electrode, and to remove it, you take this out, take also this out and put it in the glass cell like this. This goes and fits here directly. This you can adjust. Okay, this you can adjust, and then after using it, clean it with dry water and put it like this. This is also the same filling solution as here, so that it remains wetted all the time. Again, to refill it, call us. We will.